How's it going, everybody? And welcome to another installment of YouTube's Ask Me Anything. Based off of the question I asked about the ENARSI workbook and things like that, 17 likes, and I have probably, 6 or 7 comments on it, and half of them were, I like the idea. So I'm working on developing, you can't see the whiteboard behind the camera, but I developed a topology, if you will, of by looking at all the exam topics and what I'm going to do about that. So I'm going to start developing a workbook for ENARSI. And as I was sitting here last night after I released the last AMA video, the um, the my the cog started spinning, right? And so I'm going to actually flip over to the comments section here so we can go over some of the comments that were left and things like that. We'll start to answer some of these questions and go from there. I do know I need to get back to Alex's comment, so I definitely will be hitting that up. I'm probably going to focus my time and effort on that one, just because of the fact that it's a legit question. But as I was sitting here last night, I was, I get deep in thought sometimes, and all kinds of things pop into my brain, and so as I was going through that, um, the excuse me, apologies for that. Let me flip over here to the CCNP portal here, and we're going to look at the Enterprise series, or the Enterprise track. And we're going to go to Exams and Training, and we're going to look at ENARSI. We'll look at the exam details. And I am going to click on this guy, then we're going to go to Exam Topics. And then we're going to look at, do I need to wait for the pop-up? Yep, there it goes. All right, so let me just talk briefly about how I would structure this. So if you are studying for ENARSI, for example, and you are trying to come up with a game plan of how you would attack the exam, here is when I was reviewing this, I had my phone up, or I had my iPad in front of me. I had the exam blueprint pulled up, and the way that I would do this is I would attack this in 2 different stages. The first stage, let me go ahead and adjust my mic real quick. The first stage that I would do would be taking everything you learned in the Encore exam. So, and let's actually jump back to this one real quick, and we're looking at concentration exam detail. So this is the one I want. $400. Well, that's actually not that bad considering the old written exam was $450. So we'll look at the exam topics. Well, let's take a look at this. So if you were to take a look at how the exam blueprint is laid out for ENARSI or for Encore, there are, and I'm going to break this out just a little bit so that it makes more sense. If you took the chunks of what's here in the Encore exam for doing your typical enterprise design for a 2 or 3 tier fabric. So when they say 2 tier, 3 tier, and then fabric simply means either a SD access fabric or a data center fabric. And the data center fabric would be something like a spine leaf architecture. That's what they refer to that. And cloud. High availability, FHRP, stable switchover, things like that. And then we're going to skip over wireless because we're not focused on that. We're not going to look at SD-WAN or SDA. We will look briefly at wired QoS. And then, so these are the things that you would want to focus on for main operations. So the way I was looking at this was, okay, if you take infrastructure, you take your layer 2, your layer 3, and your services, and you focus on those things. So we're going to talk about EIGRP and OSPF, and OSPF v2, v3, and then eBGP. There's not a lot here, to cover it, and then they say describe PBR. So you take these aspects plus you take NTP, point provision time protocol, or which is PTP, NAT, PAT, HSRP, VRP, and then multicast. And you take all of these other things that come into play, like access lists, control plane protection, and policing. Actually, this is control plane policing, not protection. But it could be deferred to as that. Then you have your security design, things like that. So if you take the main pieces that are routing and switching centric, and you look at the ENARSI exam, I would build this out in a taking what you've already done for Encore. You know, assuming that you're following the lab flow for this, where you're learning what you need to learn. For example, here they have load balancing, path selection, path operations, metric area types, configure simple OSPF v2, v3, including multiple normal areas, summarization and filtering, neighbor adjacency, point-to-point broadcast, passive interface, basic stuff, right? Anything that would taking what you learned in CCNA and taking it a step further. That's essentially what you're doing here. Well, if you look at the ENARSI topics, they talk about doing the exact same thing. Address families, v4, v6, neighbor relationship and authentication, area types, the network types, the area types, internal router, ABR, ASBR, and then virtual link. And then path preference. OSPF internal routes versus inter-area versus N1, E1, E2, N2, so on and so forth. So if you take that flow, right, and if you were to think of it like a rock going downhill, or actually probably a snowball as it gathers speed down, that's going to gather more snow, eventually your knowledge base is going to grow. That's essentially how I see myself doing. The ENARSI would be broken up into two different sections. The first section would be focused on the implementation pieces of all the major technologies. So the topology that I'm developing, I don't have it labbed out in Eve yet. That's something I'm going to be actually working on today for a little while, is building that out so that it is a internet-based connections. We have MPLS. There will be several locations. There will be one big main location. There will be two medium-sized sites, and there will be a handful of smaller sites. We'll take a look at IPsec. We'll take a look at DMVPN, GRE tunnels, MPLS VPNs, BGP, NAT, all those things that come into play. And then once we have the topology fully built out based off of getting everything implemented off the core exam, right? We'll take the core exam main pieces, right? We'll take all of these things that you need to configure. And then, now there's no mention of MPLS that I can see here in this section. They don't even cover it. But in ENARSI, they do underneath the VPN technology. So they talk about describe MPLS and layer 3 VPN. Well, here's the thing. It's easy to describe it, but if you don't understand it or have gone through it, these are going to be the areas you're going to struggle in. So we'll be going through a full MPLS VPN deployment. So my goal is anywhere it says in the core exam, we're going to go focus on implementing said technology, but in ENARSI, which is actually the replacement for T-Shoot from the old CCNP, it says troubleshoot and all these technologies. Well, that would be the next stage. So what we would do is we would build out a fully baked in lab. So everything that you see there's a troubleshooting scenario here, we would bake in to our deployment. And then what we would do, and this is how I studied for my routing and switching lab, was we would systematically break it. So I fully build out a topology with all the bells and whistles based off of somebody's comment about taking all the blueprint topics for a particular exam, build one big topology out of it, build everything else so you know how to build it all up, configure, verify, get end-to-end reachability, all the things that you're going to be using to learn how to do the real world work, and then systematically break it. Where we'll do PBR, VRF Lite, summarization, redistribution, loop prevention mechanisms, route map, administrative distance. We'll take a look at all of those things and how they come into play, and then we'll take a look at troubleshoot EIGRP and named and in classic mode. I've got two EIGRP locations that we're going to go dive into. Same thing with OSPF and BGP. We'll have a We'll have the build, right? We'll go through and deploy everything, get it fully working. We'll simulate a CCIE size lab just to give you the big picture of what's going on. And then as it's built out and we go through the individual pieces in the workbook, then there will be a dedicated section where there will be, say, I don't know, I'm just looking at the size of the topology. I'm guessing somewhere in the neighborhood of between 30 and 40 troubleshooting scenarios. And we're going to break it down based off of the different variations. So I don't know, I haven't taken the ENARSI exam, so I don't know what they're actually going to ask you to troubleshoot. But the bottom line here is if you understand how the technology works from the get-go, then it'll be that much easier for you to troubleshoot things down the road. Because the old adage that was explained to me a long, long time ago was you cannot troubleshoot something you don't understand. It's like somebody brings, like, I'm not a car guy, right? I understand the basics of you need to put gas in the gas tank, you need to put oil in the engine, there's this, whatever the term is, I can't think off the top of my head. You put oil so that 4 or 5 containers of oil, so the engine runs smoothly. You've got your antifreeze, you've got your water for your radiator. You got all these pieces, parts and whatnot to make the car run. So if the car starts acting up, regardless of what it is, I'm not a mechanic, right? So I don't know the individual parts of the car well enough to be able to troubleshoot the problem myself. Like I can Google it, like, okay, my car is doing X, and then but you're going to get 10,000 results. So what do? I take it to somebody to fix it, and then I had to pay out of pocket because I don't have the knowledge to be able to do it myself. Do I want to? I mean, I'm not a car guy. I just, do I want a Mustang GT that I can flip into a convertible, and when I turn the key on, it comes to a throaty rumble? Absolutely, that would be awesome. But it's just not on the cards for me as being with 2 kids and a wife. It just doesn't work. So maybe when my kids get older and we're no longer financially responsible for them, maybe things will change. But the reality of it is that would be a cool car for me to be able to drive around and stuff like that. So I want to have some toys when I get a little bit older, and I don't have to be like, oh, well, I can't go buy that because my kid needs this instead, So anyway, the bottom line here is if you know how the technology works under the hood, literally what my analogy was for, if I don't know how to fix something, I take it to somebody that does. And I'm able to troubleshoot the problem. So that's exactly what we're going to do. It'll be a full build out, and then we're going to troubleshoot the problem. So I'll walk you through, okay, how do you identify where the problem is? How do you know what to look for? Because it's a lot of pattern recognition, right? If you can look at something, and we're not just going to look at a show run and look for what's ever missing. We're going to look at the outputs, because that's what the exams are going to give you. They're going to give you a screenshot of a given scenario, and they're going to say, okay, based off the exhibit above, tell me what's wrong. And that's going to be your job to be able to examine it and go, that's not right. And then you click on the button, boom, you got your credit for it because you knew what you were looking at. So that is the goal. We're going to follow the exam blueprint because that's what we have. So I'm not going to get into super complicated networking. This will be a little bit more advanced, but it's supposed to be. It's the advanced infrastructure implementation. They're expecting you to be knowledgeable in this type of stuff. So are we going to fully deploy MPLS? We are. We're going to walk through how to do everything. We will have it fully baked out, full connectivity, route advertisements, the whole 9 yards. It's really not that hard. You're going to realize that when we do the build, that the individual pieces aren't that difficult to do. But as we get through the pieces and the capabilities, the other thing that I want to point out too is as I'm going through this, it won't be a best practice breakdown of how you would do stuff. It'll be specifically geared to help you guys have a flow that is meant to help you take, maybe you're struggling in a particular area of a routing protocol or design. It's meant to help you work through that, and you guys will definitely be able to reach out and ask, for help on things and stuff like that, and I'll help you out the best I can. But the goal is to have a concerted amount of time and effort put it in to get this thing stood up. So you have to be able to build it first. If you know how to build it, and you know how to verify it, and you know how to troubleshoot it, then the next thing would be to do what? For those of you that are getting into like automation, you'd be able to build out something like Ansible or Python scripts that would do the work for you. That's something I'm learning for service provider when I take a look at the network services orchestrator, and I'm having to learn. But this is the part that I think is going to be valuable. Now I'm going to pivot just a little bit. So the other thing I got to thinking about was maybe I do the same thing for a CCNA, where I write a CCNA workbook where we take a look at the CCNA topics and I walk you through how to deploy everything on there that I have access to, and then stuff for like the security VPN course or service provider and wireless or the firewalls that are out there, and then potentially SD-WAN, or I do a full SD-WAN one. But because I'm finding that there's not a lot of official certification guides out there for a lot of stuff, and a lot of things that you guys are asking for, it's like, well, if it doesn't already exist because Cisco either doesn't think there's enough market share for them to be profitable, because at the end of the day, it's what it is. It's profit and loss. How much money and time needs to go into the book, and how many people are going to buy it. That's really what it comes down to. For me, it's just that's not how I look at it. It's like if there's a need, even if it's a small need, if there's a small amount of demand, why not capitalize on it? Write a book that's relatively inexpensive. I'm probably going to charge like I do for the enterprise book, where it's $50. It's a one-time charge. You get it, it's yours, and then you get updates over the period of time. So that's essentially what I'm trying. That's my goal with that. So that's I've got the topology developed on my whiteboard, and then my goal would be to take the next little bit. I don't know how long it's going to take me to put out. I'm thinking probably a couple of months to write it. And then once it's written, I probably will have a handful of you that are interested. I will give some copies away as a technical reviewer, and let you guys give me some feedback on whether or not this works for you and things like that. And with the goal of it being a known good configuration guide. This is how you would get a particular thing working. It's not going to be a technical deep dive in how BGP VRF Lite works. It's not going to be that. That's going to be on you to learn. But my also goal is to have there's already a lot of content on the channel already for this, so I don't have to spend a lot of time going through and spending time just explaining how the technologies work. The book is going to be there as a known good configuration guide to try to help you through those processes and go from there. So if that's something you guys would be interested in doing, let me know in the comments. Like, subscribe, all that good stuff. So let's go ahead and flip back over here, and we're going to take a look at Alex's question here. And the question is, I also think that just layer 2 link trunk between distribution switches is the best design. You also mentioned that it's possible to run routing protocols with SPIs over layer 2 link trunk between distribution switches, and you wanted to explain something about it, and then your attention was switched to another question. Could you please tell me more about this design? I think it's not very usual design, in which kind of scenarios it can be useful. So typically speaking, the way you would do this is, and what he's describing here, let me go ahead and pull this out real quick, is a very simple breakdown. Let me go ahead and pull my pen tool out here and move some stuff out of the way. Let me switch to black. All right, so what he's describing is you have, say, core 1, you've got core 2, you've got distribution 1, you've got distribution 2, and then you have, say, access 1, and then you have access 2. And let's just say that there's some sort of, I'm going to draw a cloud here. These guys connect up to the cloud. There's maybe connectivity between them, but we're not, something like this. And we're going to draw like this. This is going to be the connectivity. And in between, you're more than likely, if you're not doing any type of chassis aggregation, so there's no VSS, there's no Stackwise, none of that stuff. What you're going to end up doing is you're going to build probably two 10 gig links between your distribution switches. And what I meant by this is you're going to run a bunch of SPIs on each side. So you'll have SPIs here, and you'll have SPIs here. Now maybe it's a misunderstanding, but most of the time when you're doing this and you're announcing your SPI subnets into whatever routing protocol you're running, let's say this is EIGRP. Well, what you're going to do is you're going to be running EIGRP between your cores and your distribution block, and you're going to advertise your SPI subnets into EIGRP. Now, what that means is you're going to be able to form EIGRP adjacencies over this link. That's what I meant by that. So not a very usual scenario. It just, maybe you just haven't been exposed to it. But it is a very common thing. Now, here's the thing. When we start looking at network design and we start looking at how traffic patterns will flow, the thing that you have to take into consideration is, do I care whether or not there's an EIGRP adjacency between these two? It depends. So I'll give you the first example that I usually explain when I'm talking to customers about this type of stuff. Is this. If I want to have a traffic pattern that I have my traffic go this direction outbound. Okay, so distribution 1 is my spanning tree root bridge. It's also my first hop redundancy, like my HSRP active box, or my primary. And then distribution 2 is just backup for that. And you can do this on a per VLAN basis. So just for the sake of argument, we're going to assume all VLANs are going via distribution 1 and out to the internet via core 1. Now, in the event that there's a problem, and we'll say, for example, that this box dies, distribution 1 is no longer operational, then what happens? Well, the network's got to reconverge. Well, I'm going to say at a high level that the device dies power outage. For whatever reason, the box doesn't have any power. Well, spanning tree is going to reconverge, and now everything is going to flow out through distribution 2, and then out through core 2, out to wherever it's got to go. That's going to be the failover. So that's one scenario. Does that work? Yes, it does. Do I have to worry about HSRP or whatever my first hop redundancy protocol is? No, I don't, because all of those messages can either go over this point-to-point link that's doing it. It's a trunk, but also can form dynamic routing adjacencies over the trunk via the SPIs. Am I doing that in this particular case? In this particular case, no, I would not do that. Now, how would you prevent that from happening? Well, what you would do is underneath EIGRP, you would go to your, we'll say router EIGRP 1, and then you would type in here passive, I'm just going to shorten it up, interface, and I would do default. What that means is I'm not going to allow EIGRP to form any adjacencies on any subnet, meaning I'm simply going to not allow EIGRP hellos to be sent or received on any interface that's got an IP address that the network statement has been applied to. That's what that means. So what then I have to do is I have to selectively enable which interfaces I want EIGRP to send and receive hellos on. So then I might say no passive interface, let's say gig 0/0 and 0/1. So this link here, and or maybe this link here if there was one, right? So just the upstream link, right? So what that's going to allow it to do is distribution 1 will be able to talk to core 1 and core 2 and form EIGRP adjacencies. Everything will be hunky-dory. That'll work just fine. And that is, in my opinion, that is the best practice. You don't want to, typically speaking, you don't want to form EIGRP or dynamic routing protocol adjacencies over your trunk link between your distribution switches. Can you? Yes. If you do allow that, does that cause any problems? No, it's not going to hurt anything, and it actually gives you a little bit of flexibility. Now, for the sake of argument, let's just say, for example, that this box right here, distribution 1, is actually fine, but for some reason, structured cabling went down. Let's say that this link goes down between distribution 1 and access 1. So what ends up happening? This is a very, or the SFP on the box or the port on the switch dies. What do you do then? Well, in this particular case, then what will end up happening is access 1 will no longer go through distribution 1. Access 1 will flow through distribution 2 to get to where it's got to go. And access 2 will continue to flow through distribution 1. Why? Because only the link between distribution 1 and access 1 went down. Access 2 still has access to it, and it still flows through it. So access 1 goes through distribution 2, but access 2 goes through distribution 1. Now, is there any problem with that? No. But here's the rub, the interesting part. EIGRP is still enabled, and where distribution 2 has a default route via distribution 1 to get out to the internet. But Rob, why would he flow over this way to go up there? Because that's the routing design. That's an example of one. Now, do you have to go that way? You don't, no. There might be some reason why you're going this distribution 1 via core 1 versus distribution 2 and core 2. Now, I'm just giving you some hypotheticals here. But right here, I think this is not a very usual design. That's the opposite. So the only difference between this design and the other one that I described is whether or not you enable this command right here. Whether you enable your distribution switches to be able to form dynamic routing adjacencies over the trunk link with each other. That's it. That's the only difference between the two. And is there any problem with that? There is none. There is none. I would suggest, and at least in my experience, what I would do, unless there's a specific or compelling reason from the customer to not do that, I wouldn't turn it off. What do I lose? You don't lose anything. As a matter of fact, you gain a path if you don't enable passive interface default. Now, it's just a personal preference. Am I wrong in that? No. But I have had customers say, I don't want to form EIGRP over the link between the two. I simply just want to go through and have it point due north out of the gate. Cool. Passive interface default, and then no passive interface on your uplinks. Problem solved. You lose a diverse path. So if something were to happen from your distribution layer going down to your access layer through structured cabling or an SFP going bad or a port on the switch not working anymore, then that's a different situation. So in those type of situations, you would have to take into consideration that you would be losing a diverse path. So does it matter? One half doesn't do anything better than the other. So you just have to take into consideration what's going to end up happening. And if you want to test this out, go ahead. Spin up a few devices and then simulate some routing and see exactly how it comes out to be. And then turn passive interface default on, and you're going to see it go away. In the workbook, I actually demo this. If you have the workbook, I show you where we go in and we do passive interfaces, and I enable passive interfaces on all the SBIs. So we don't form a EIGRP adjacency or whatever over the trunk link between the switches. It doesn't hurt anything. You just lose a diverse path. That's all. That's literally the only thing you're losing with that. So at the end of the day, it can definitely be useful if you want it to be. So, but if a customer is just like, I'm not a big fan of that, cool, turn it off. You're not going to hurt anything, right? And I'm not going to sit there and say that it's worth having, but these are some of the things you have to take into consideration when you start to understand how things work. You're probably going to see this type of stuff pop up, and whether you understand the architecture or you don't is kind of irrelevant. Well, actually, sorry, not if you understand it or not. If you agree with it or not, it's kind of irrelevant. The reason why I say it's irrelevant is because what you need to be able to do is you need to be able to understand the routing design, and you might even have to ask somebody, hey, this is what's going to end up happening. Do you agree with this or not? This is why I talk about peer review. It's a good thing to go and, like, if you're looking at a design with somebody and you're not exactly sure which way to go, you need to be able to present both and say, I would go this way and this is why. And if some customers aren't going to have the technical know-how to say, well, I don't like that idea. Or they might be like, oh, there's a diverse path. So that's one more potential option if something was to happen where all my links from distribution 1 went down, or I'm sorry, distribution 2, or whatever the case might be. I'd be able to flow over my inter-switch link to the other distribution switch and then outbound from there. That might be a completely legitimate use case. But, when you're talking about handling every type of failure, that's going to be link and node. Having the link between the two is probably a good idea. So these are some things that just to keep in the back of your mind. And, if you don't think it's that great of a design, if you think it's better to not have the EIGRP or dynamic routing protocol adjacency over your trunk link between your distribution switches, that's your call. That's the beauty of network design. It's subjective based off the use case. So that's pretty much what it is that I was going to go break into until I got distracted. So, but anyway, hopefully it answers your question. And if you guys continue to have more questions about this type of stuff and you would like me to whiteboard out the why behind it, feel free to let me know in the comments. I'm willing to help out. So with that being said, that is pretty much it for today's AMA. So if there's any other questions you guys have, please let me know in the comment section below. And then we will definitely be taking a look at some other options down the road. And as you can see, quite a few folks have posted comments on what to do and how to do stuff, or what they would like to talk about. So I will be covering those in the next couple of AMAs and go from there. So if you, just as a quick reminder, Wednesday we'll have a Whiteboard Wednesday. Even though I didn't get any feedback, really good feedback anyway, on whether or not you guys want a Teams chat available, I'm probably just going to open it up anyway and see how it goes. Maybe that's a bad idea, but I get a handful of comments. It depends on if you're comfortable joining it or not. If you don't feel comfortable joining the Whiteboard Wednesday Teams chat or Teams call, and we can chat more like real time, and I can share in real time, then that's up to you. If you do, great. I'm going to do the same thing I do with the coaching sessions. I'm thinking it might be a little more interactive. If you have something that's out specific, or you want to talk about something, hop on, ask away. I'm happy to try to help. But there will be a link in the description for the membership to the channel through Patreon, plus the sample workbook and the actual workbook links as well. And until next time, guys, it's been nice talking to you, and I'll catch all of you in the next one.